All right, let's talk about what is, no joke, one of the most influential academic books of the entire 20th century. We're going to unpack the huge ideas from a text that completely flipped our understanding of progress on its head.
And look, that quote right there, great books are rare, this is one. That is not an exaggeration. We're talking about Thomas Kuhn's The Structure of Scientific Revolutions, and that line, it just sets the stage perfectly. This is a book that left a permanent mark on how we even talk about big ideas.
I mean, you've heard this phrase a million times, right? Paradigm shift in business, in tech, even in art. People throw it around. Oh, it's a total paradigm shift. But where did it actually come from? Well, it has this super specific, way more fascinating origin story that comes straight from this book. And if you get this, you really start to get how knowledge itself actually changes.
All right, so let's get to the heart of this world-changing idea.
So the guy behind this whole thing was Thomas Kuhn. And what's so interesting is that he started out as a physicist, right? So he had that insider's perspective. But then he switched gears and became a historian of science. And it's that unique combo that let him see this pattern, this rhythm in the history of science that really no one had put their finger on before. And this is the pattern he found. This is Kuhn's cycle of science. And what it shows us is that progress, it's not some straight, neat line. It's more like a loop, dynamic, sometimes even a little chaotic. So think of this cycle as a roadmap for the next few minutes. We're going to start right at the top with something he called normal science.
So first up, we've got to get a handle on what scientists are actually doing day in and day out. And, it's probably not what you're picturing.
Yeah, forget those big eureka moments. The apple falling on the head. Just for a second, Kuhn said that most of science, the day-to-day grind, is what he called normal science. And a great way to think about it is like solving a puzzle. Not making a dramatic discovery, but just methodically working on a crossword. The rules are already there, the goal is clear, and you're just patiently filling in the empty boxes.
Okay, so what are these puzzles? Kuhn breaks them down into three main types. Sometimes it's about nailing down the facts, like getting a more and more precise measurement of something. Other times it's about making sure those facts line up with the big theory everyone's using. And then sometimes it's about tweaking or sharpening the theory itself. But here's the crucial part. None of this work is trying to break the system. It's all designed to reinforce the existing rules, to make them stronger.
So, where do the rules for all this puzzle solving come from? Well, this brings us to the big one, the central idea, the paradigm. And using Kuhn's own definition, a paradigm is a scientific achievement, think Newton's laws or Einstein's theory of relativity, that's one, so groundbreaking it gets a whole bunch of scientists on board, but also, two, it's open-ended enough to leave them with tons of new puzzles to work on. It's basically the shared playbook, the map everyone agrees to follow.
But here's a fun fact. The word paradigm, it's actually notoriously slippery. In fact, one critic went through the original book and found that Kuhn himself used the word in, get this, 21 different ways, which just goes to show you how rich and complex this single idea really is.
Okay, so you've got your scientists, they're working away inside their paradigm, happily solving all their puzzles. But what happens when they hit a puzzle that just refuses to be solved?
And that's where we meet the anomaly. An anomaly is a result that just won't play by the rules. It doesn't fit. It's that one stubborn piece of data that contradicts everything the paradigm says should happen. The word even comes from the Greek for contrary to law, which is perfect because that's exactly what it is. It's a glitch in the matrix of their scientific world.
Now, at first, scientists might just ignore an anomaly, or they'll try to find a way to explain it away. Oh, it was a measurement error. But what happens when the anomalies start piling up? Or when one is just so big and glaring you can't ignore it anymore? Well, that's when the whole community enters what Kuhn calls a state of crisis. Suddenly, the trusted old rules don't seem to work. It's this time of profound professional anxiety, where the very foundations of their science start to feel, well, pretty shaky. And this crisis, it's the essential spark. It's the trigger for the most dramatic part of Kuhn's entire cycle, the revolution. This is where everything, and I mean everything, changes.
And this is just a brilliant way to see the logic in Kuhn's own argument. I mean, look at the actual table of contents from the book. He lays it all out, step by step. He moves from crisis to the response to crisis and right into the nature and necessity of scientific revolutions. He even calls them changes of worldview. This isn't just a random accident, it's a built-in part of the process.
Okay, so here's a really crucial, kind of mind-bending idea. You can't just line up the old paradigm and the new one next to each other and say, okay, which one is better? It's not that simple. Kuhn used a big word for this, incommensurability. It basically means you can't measure them with the same ruler. It's like they're speaking different languages. The definitions of core words have changed, what counts as good evidence has changed, even the questions they think are important to ask have completely changed.
The perfect example of this is Newton versus Einstein. In Newton's world, mass is pretty simple. It's a fixed property of an object. It just is what it is. But in Einstein's world, mass is totally different. It's relative to speed, it's connected to energy. So they're both using the same word, mass, but they're talking about two fundamentally different concepts. That is incommensurability.
So if you can't even directly compare the old paradigm with the new one, what on earth does that do to our whole idea of progress? This might be Kuhn's most radical, most challenging idea of all.
Kuhn basically forces us to completely rethink what progress even means. We tend to imagine science as this straight line, just piling up facts, getting closer and closer to some final capital T truth. But Kuhn suggests a totally different way of looking at it. For him, progress is more like evolution. It's not about moving towards some fixed goal. It's about moving away from something that's broken, a system that just can't handle the puzzles and anomalies anymore.
So a paradigm shift isn't just adding a new chapter to the textbook. It's like throwing out the old textbook and writing a completely new one. It redraws the entire map of science. It changes what questions are even considered scientific, what problems are worth a scientist's time. Something that was a central mystery for a century might suddenly become totally irrelevant, and an idea that was once considered completely nuts can become the new normal, the new common sense.
And all of this leaves us with a huge question, really the core challenge of Kuhn's entire book. What is science actually doing? Is it on a steady march to uncover some final objective truth that's just waiting out there for us? Or is it something else? Is it a series of revolutions, each one giving us better and better tools, more useful models for solving new kinds of problems? Kuhn doesn't hand us the answer, but what he does, and what's so powerful, is give us a whole new way to think about the question.